Friends, in previous video, we have studied some concepts of chapter probability distribution like variables and their probabilities. In this video, we will discuss about expected value and variance of a random variable of chapter probability distribution. Now, first concept is expected value or mean of a random variable. Its definition is let x be a random variable whose possible values x1, x2, x3 up to xn occur with probabilities p1, p2, p3 up to pn respectively. The expected value or arithmetic mean of x is denoted by E of x. E of x means expected value of x, or mu as a sense of mean is defined by E of x is equal to summation of xi into pi. Here xi is variables and pi is their corresponding probabilities, is equal to x1 into p1 plus x2 into p2 plus x3 into p3 plus up to xn into pn. I repeat this again. Let x be a random variable whose possible values x1, x2, x3 up to xn occur with probabilities p1, p2, p3 up to pn respectively. The expected value or arithmetic mean of x denoted by E of x or mu and is defined by E of x is equal to summation of xi into pi, I from 1 to n. That means x1 into p1 plus x2 into p2 plus x3 into p3 plus up to xn into pn. This, in other word, we can say as the mean or expectation of a random variable x is the sum of the product of all possible values of x by their respective probabilities. The mean or expectation of a random variable x is the sum of the product of all possible values of x by their respective probabilities. Next concept, variance of a random variables. Its definition is let x a random variable whose possible values x1, x2, x3 up to xn occur with probabilities p1, p2, p3 up to pn respectively. The variance of x denoted by var of x but read as variance of x or sigma x square. Now let x be a random variable whose possible values x1, x2, x3 up to xn occur with probabilities p1, p2, p3 up to pn respectively. Variance of x is denoted by var of x or sigma x square and is defined as sigma x square is equal to summation of in bracket xi minus mu bracket square into pi, I from 1 to n. Here xi is possible variables, mu is a mean and pi is a corresponding probabilities of xi. This is a formula of variance. Now, taking non-negative square root of variance, that means it is a sigma x. Sigma is equal to root of variance. It's called standard deviation of a random variable. Now I repeat again, taking the non-negative square root of variance is called standard deviation and it is denoted by sigma x. Now this formula of variance, now simplify. This is the formula of variance. Now this simplify in another form. Now here this bracket. Now taking the square of this bracket, then we get summation of in bracket xi square minus twice xi into mu plus mu square into pi. In next term, now multiply this pi to each term and also provide this summation to each term. Then we get first term summation of xi square into pi. In second term, twice mu is a constant, therefore it is out of summation and multiply pi. Then we get twice mu summation of xi into pi plus in third term mu square is a constant, therefore it is out of summation of pi. Now in next term, now see this. In next step, see this second term. This is nothing but a mean. Now this is the summation of xi, pi is a mean. Now put here summation of xi, pi is mu because mean is denoted by mu. Therefore second term is twice mu into mu, that means twice mu square. Now in third term, summation of pi, we know that the sum of all probabilities is 1, therefore put here summation of pi is 1, then we get third term is mu square. Now in next step, adding second and third term, then we get minus mu square. First term as it is, taking the sum of first and second and third term, then we get minus mu square. But here mu is equal to summation of xi into pi. Put here mu is equal to summation of xi into pi. Then we get variance of x is equal to sum first term as it is, second term summation of xi into pi bracket square. But first term is a expectation of x square and it is denoted by e of x square, and second term is an expectation of x, and expectation of x is denoted by e of x and its the bracket square means e of x square. This is a new form of variance, formula of variance. Now some examples on mean and variance. Find the expected value and variance of x where x is number obtained on uppermost face when a fair die is thrown. I read the question again. Find the expected value and variance of x where x is number obtained on uppermost face when a fair die is thrown. Its solution: let x be a number obtained on a throw. Now here I throw a fair die. I throwing a fair die. Then we get possible outcomes. These are possible outcomes. These are 6 outcomes. First is 1, second is 2, third is 3, fourth 4 number. These are totally so on. These are totally 6. Now the possible values of x. So the value of x can be 1, 2, 3, 4, 5 and 6. These are the variables. So now find the corresponding probabilities, their corresponding probabilities. The probability of getting of each number is equal. probability of getting of each number is equal. Therefore, P of 1 is equal to P of 2 is equal to P of 3 is equal to P of 4 is equal to P of 5 is equal to P of 6 is equal to 1 by 6. Okay. The probability of each number is 1 by 6. Now, therefore, probability distribution is as follows. Now, we can write the probability distribution is tabular form. Here, xi means variables. Now, here I write in column form. First column is column of variables. Second column is column of respective probabilities of xi. Now 1, probability of 1, corresponding probability of 1 is 1 by 6. Probability of 2 is 1 by 6. Also probability of 3 is 1 by 6, so on. Now third column is a xi into pi, product of xi into pi. Now here xi is 1. 1 into 1 by 6, 1 by 6. 2 into 1 by 6, 2 by 6. 3 into 1 by 6, 3 by 6. 4 into 1 by 6, 4 by 6. 5 into 1 by 6, 5 by 6. 6 into 1 by 6, 6 by 6. Now, taking the addition of this column, this is a summation of xi into pi. It is 21 by 6. It is 21 by 6. It is also called, it is a E of x means summation of xi into pi is a expectation of x. Now, third column xi square into pi. Xi square into pi. That means first column square into second column. 1 square 1. 1 into 1 by 6, 1 by 6. 2 square 4. 4 into 1 by 6, 4 by 6. 3 square 9. 9 into 1 by 6, 9 by 6. 4 square 16. 16 into 1 by 6, 16 into 1 by 6. 16 by 6. 5 into 1 by 6. 5 square 25. 25 into 1 by 6, 25 by 6. Now 6 square 36. 36 into 1 by 6 is 36 by 6. Now taking the sum of this column, this is a summation of xi square into pi. This is a expectation of x square and it is 91 by 6. But we want mean means expectation of x and its formula is summation of xi into pi. But here we find summation of xi into pi is 21 by 6. 21 by 6. But here 3 is a common factor. 3 get cancelled. Remaining is 7 by 2. Next, we want variance of x. Now its formula is summation of x. Variance of x is expectation of x square minus expectation of x bracket square. Here expectation of x square is 91 by 6 and expectation of x is 21 by 6. Therefore 21 by 6 bracket square. Now solving this, then we get variance is 35 by 12. Therefore the solution of this question, expectation of x is 7 by 2 and variance of x is 35 by 12. Now next example. Find the mean number of heads on 3 tosses of a fair coin. Now let x denote the success of getting head. Here I consider let x denotes the success of getting head. Therefore, the sample space is, this is a sample space. Sample space means collection of possible outcomes. It's called sample space. Now, it can be seen that X can take the values 0, 1, 2 or 3. 0 means no head in outcome. 1 means only one head, 2 means only two heads, and 3 means all heads. Now, therefore, P of X is equal to 0. That means P of no head acquire. There is only one outcomes out of 8. Therefore, this is T T T. Only one outcome out of 8. Therefore, its probability is 1 by 8. Now, probability of 1. Therefore, P of X is equal to 1. That means P of one head acquire. That means in outcome only one head. See these three outcomes: H, T, 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 H, T and T, T, H. Here only one head. 3 outcomes out of 8. Therefore, its probability is 3 by 8. Now, next, probability of X is equal to 2. That means P of 2 heads acquires. That means in outcome there is 2 heads. Now see, second outcome, third and fourth. There is 2 heads. 3 outcomes out of 8. Therefore, its probability is 3 by 8. Now last, probability of X is equal to 3. That means P of 3 heads acquires. This is only one outcome out of 8. Therefore, its probability is 1 by 8. Now, therefore, the required probability distribution is follows. Here we want mean. Therefore, the formula of mean is mu. Mean is denoted by mu and it is equal to summation of xi into pi. Here xi is 0, 1, 2, 3 and pi means their corresponding probabilities. Probability of 0 is 1 by 8. Probability of 1, 3 by 8. Probability of 2, 3 by 8. And probability of 3 is 1 by 8. Now putting here, then we get 0 into 1 by 8 plus 1 into 3 by 8 plus 2 into 3 by 8 plus 3 into 1 by 8. And solving this, here 0 into 1 by 8, 0. 1 into 3 by 8, 3 by 8. 2 into 3 by 8, 6 by 8. And 3 into 1 by 8, 3 by 8. Now, denominator is same. Taking the addition of numerator. Addition of numerator is 3 plus 6 plus 3. Means 12. 12 by 8. 12 by 8. Here 4 is a common factor. 4 get cancelled. Then we get 3 by 2. Now this is in fraction form. Now converting in decimal fraction. In decimal fraction answer is 1.5. Therefore, required answer is mean of X is 1.5. Now next example. 2 dice are thrown simultaneously. If X denotes the number of sixes, find the expectation of X. I read the question again. 2 dice are thrown simultaneously. If X denotes the number of sixes, find the expectation of X. Now its solution is here. X represents the number of sixes obtained when 2 dice are thrown simultaneously. Now here I throw 2 dice simultaneously. Then we get the possible outcomes. These are the possible outcomes. Total outcomes is 36. Now I write in sample in set form. This is called sample base and it is denoted by S. Total outcomes are 36. Therefore, now see this black color outcomes. There is no 6 on first die or second die. Now blue color, now blue color's outcomes. In blue color's outcomes, 6 on first die or second die, not on both. And last, only one outcome, the orange color. This on this outcome, 6 on both dies. 6 on both dies. Therefore, x can take the values 0, 1, 2. 0 means no 6 on first die or no 6 on second die. 1 means 6 on first die, not on second, or 6 not on first die, 6 on second die. 2 means 6 on both dies. Now P of x is equal to 0. That means P of no getting 6 on any of the dies. Therefore, here 25 dies. There is no 6 on first die or second die. No 6 on second die. Total outcomes are 25 out of 36. Therefore, its probability is 25 by 36. Next, P of x is equal to 1. That means probability of 6 on first die and no 6 on second die plus probability of P no 6 on first die and 6 on second die. Now see here, no 6 on second die, 6 on first die. These are 5 outcomes. Therefore, 6 on first die and no 6 on second die. These are 5 outcomes. Therefore, its probability out of 36. Therefore, its probability is 5 by 36. And no 6 on first die and 6 on second die. These are 5 outcomes out of 36. Therefore, its probability is 5 by 6. Therefore, the probability x is equal to 1 means probability of 6 on first die, no 6 on second die. Its probability is 5 by 36. And probability of no 6 on first die and 6 on second die. Its probability is also 5 by 6. 5 by 6, sorry, 5 by 36 plus 5 by 36 means 10 by 36. Now next, P of x is equal to 2. That means probability of 6 on both the dice. This is only one outcomes. Order pair 6 out of 36. Therefore, its probability is 1 by 36. Now, hence, the required probability distribution is as follows or as follows. Hence, the expectation of x, it is denoted by E of x. Its formula is summation of xi into pi. Now, putting these values, probability of 0, 25 by 36. Probability of 1, corresponding to 10 by 36. Probability of 2, 1 by 36. Putting these values, then we get 0 into 25 by 36 plus 1 into 10 by 36 plus 2 into 1 by 36. Solving these term, then we get 1 by 36. Now divide, this is in fraction form. Now convert in decimal fraction, it is 0.33. Therefore, required expectation of x is 0.33. Next example, two numbers are selected at a random without replacement from the first six positive integers. Let x denotes the larger of the two numbers obtained. Find e of x. I read again. Two numbers are selected at a random without replacement from the first six positive integers. Let x denotes the larger of the two numbers obtained. Find e of x. Here we want e of x means expectation of x. Now, two positive numbers can be selected from the six positive integers without replacement. First, six positive integers. Now here we this is a arrangement of two numbers out of six. Therefore, arrangement means permutation. That means 6p2. Here is 6p2. We know that the formula of permutation 6p2 means 6 factorial upon 6 minus 2 factorial. Solving this, then we get 4 factorial get cancelled. Then remaining is 5 into 6. We know that. I repeat again. This is a arrangement of two numbers out of 6. Therefore, this arrangement means then this is a permutation 6p2 and it is solved as 6 factorial upon 6 factorial 6 minus 2 factorial. 6 factorial upon 6 minus 2 means 4 factorial. 6 factorial upon 4 factorial. 6 factorial we can write as 4 factorial into 5 factorial into 6 factorial we can write as 4 factorial into 5 into 6 upon 4 factorial. 4 factorial get cancelled. Remaining is 5 into 6. 5 into 6 is 30. Therefore, 30 weights. The two positive integers can be selected from the 6 positive integers without replacement in 30 weights. Now, x represent the larger of two numbers obtained. X represent the larger of the two numbers obtained. Therefore, x can take the values of 2, 3, 4, 5 or 6. For x is equal to 2, the possible observations are here 2 is a larger number. These are total outputs are 36, but we want x represent the larger of the two numbers obtained. Therefore, then we take x can take the values 2, 3, 4, 5, 6. Here x is equal to 2. The possible observations means here 2 is larger number. 1, 2 and order pair 2, 1. These two order pairs out of 36. Therefore, probability of 2 x is equal to 2 is 2 by 36. 2 by 2 by 30. Now, the possible observations out of 2 observation out of 30. Therefore, its probability is 2 by 30. Now, 2 is a common factor. 2 get cancelled. It is 1 by 50. Now, for x is equal to 3. That means 3 is a larger number. The possible observations. These are possible observation. 1, 3, 2, 3, 3, 1 and 3, 3. Here 3 is larger number. 3 outputs out of 30. Therefore, its probability is 4 by 30. So, probability of x is equal to 3 is 4 by 30. But 4 is a 2 is a common factor. To get cancel, here remaining is 2 by 15. Now for x is equal to 4, means 4 is a larger number. The possible observations, these are possible observations: 1 4, 2 4, 3 4, 4 3, 4 2 and 4 1. These are 6 observations out of 30. Therefore, probability of x is equal to 4. It's 6 by 30 because outputs are 6. Favorable outcomes. Outputs are 6 out of 30. Therefore, its probability is 6 by 30. Here 6 is a common factor. 6 is get cancelled. Remaining is 1 by 5. Therefore, probability of x is equal to 4 is 1 by 5. Now, for x is equal to 5, the possible observations are: x is equal to 5 means larger number is 5. These are possible outcomes. Total outcomes are 8 out of favorable outcomes are 8 out of 30. Therefore, the probability of x is equal to 5 is 8 by 30 because favorable outcomes is 8 out of 30. Therefore, its probability is 8 by 30. Here 2 also is common factor. To get cancelled, its answer is 4 by 15. Now, next, for x is equal to 6. X is equal to 6 means 6 is a larger number in these two numbers. The possible observation, these are possible observations. Okay. Now, these are 10 out of 30. Therefore, P of x is equal to 6. Favorable outcomes 10 out of 30. Therefore, probability of 6 is 10 by 30. Here 10 is a common factor. 10 get cancelled. Answer is 1 by 3. Hence, the required probability distribution is, now here we want expectation of x. We know that the expectation of x is equal to summation of xi into pi. Putting these values here, then we get 2 into 1 by 15 plus 3 into 2 by 15 plus 4 into 1 by 5 plus 5 into 4 by 15 plus 6 into 1 by 3. Now taking the product, 2 into 1 by 15 means 2 by 15. 3 into 2 by 15s. Now here 3 get cancelled, remaining 2 by 5. 4 into 1 by 5 means 4 by 5. 5 into 4 by 15. Here 5 get cancelled. Here remaining 3 means 4 by 3. And last 3 get cancelled. Last term is 2. Now taking addition, then we get 70 by 70 upon 15. Here 5 is common factor. 5 get cancelled. Final answer is 14 by 3. Therefore, required expectation of x is 14 by 3. Next example. Let x denotes the sum of the numbers obtained when two paired dice are rolled. Find the standard deviation of x. Let x denotes the sum of the numbers obtained when two paired dice are rolled. Find the standard deviation of x. Now, so its solution, let x denote the number of, here let x denote the sum of the number of numbers obtained when two paired dice are rolled. I repeat again, let x denotes the sum of the numbers obtained when two paired dice are rolled. So x may have values 2, that means the outcome is 1 1, then 2, minimum lowest outcome is 1 1. Therefore the value of x is 2 and highest outcome means getting 6 on both dice. That means 6 plus 6 12. That so x may have values 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. Now these are outcomes. On 1 1 on both dice, then their sum is 1 plus 1 means 2. Here first column is values of x means variance. Now so on. And last 6 on first die and second die, and its sum is 6 plus 6 12. Same manner, these are outcomes. Now here third columns. First column is column of variables, second column is column of outcomes, and third column is number of outcomes. Here one outcome in for x is equal to 3, 2 outcomes. For x is equal to 4, 3 outcomes. For x is equal to 5, 4 outcomes. So on. And for x is equal to 12, 1 outcome. Now, these are total outcomes are 36. So, the required probabilities, last column, column 4 is corresponding probabilities of xi. Now, for x is equal to outcome is 1 out of 36. Therefore, its probability is 1 by 36. For x is equal to 3, outcomes is 2 out of 36. Therefore, its probability is 2 by 36. For x is equal to 4. Here we get favorable outcomes are 3. Therefore, out of 36. Therefore, its probability is 3 by 36. For x is equal to 5, favorable outcomes are 4 out of 36. Therefore, its probability is 4 by 36. So on. We get the probabilities. I repeat again, the probabilities for x is equal to 2 is 1 by 36. For x is equal to 3, 2 by 36. For x is equal to 4, 3 by 36. For x is equal to 5, 4 by 36. For x is equal to 6, probability is 5 by 36. Probability of x is equal to 7 is 6 by 36. For x is equal to 8, its probability is 5 by 36. For x is equal to 9, its probability is 4 by 36. And for probability of x is equal to 10 is 3 by 36. And probability of x is equal to 11 is 2 by 36. And probability of x is equal to 12 is 1 by 36. Now, this can be right is distribution, probability distribution. This is probability required probability distribution. First, here now first column is column of variables, second column is corresponding probabilities of xi. Here we write these probabilities. Now here we take the product of xi into pi. Now 2 into 1 by 36 is 2 by 36. 3 into 2 by 36 is 6 by 36. 4 into 3 by 36 is 12 by 36. 5 into 4 by 36 is 20 by 36. 6 into 5 by 36 is 30 by 36. 7 into 6 by 36 is 42 by 36. And 8 into 5 by 36 is 40 by 36. 9 into 4 by 36 is 36 by 36. 10 into 3 by 36 is 30 by 36. 11 into 2 by 36 is 22 by 36. 12 into 1 by 36, it is 12 by 36. Now, taking the addition of all these values, it is summation of xi into pi. It's called expectation of x, and it is 252 upon 36. Now, last column is xi square into pi. That means first column square into second column. 2 square 4. 4 into 1 by 36 is 4 by 36. X 3 square 9. 9 into 2 by 36 is 18 by 36. 4 square 16. 16 into 3 by 36 is 18 by 30. So on. We get the last column. Now taking the addition all these values, then we get expectation of x square, and it is e of x I square into pi. Its value is 1974 upon 36. Here we want expectation of x, and its formula is summation of xi into pi. But here we find summation of xi into pi is 252 upon 36. 252 upon 36. Here 36 is a common factor. 36 get cancelled, remaining is 7. Now next, variance of x. Its formula is summation of x square, expectation of x square minus expectation of x bracket square. Here expectation of x square is 1974 upon 36, and here e of x is 252 upon 36. That means 7. Putting these values, solve it, then we get answer is 35 by 6. Therefore, a required expectation is 7 and variance of x is 35 by 6. Now, next, we want standard deviation. But we want standard deviation. Standard deviation means non-negative square root of variance. And where standard deviation is denoted by sigma x. And it is equal to non-negative square root of variance. Now here variance is 35 by 6. Therefore here we are taking non-negative square root of 35 by 6. Therefore standard deviation is in root 35 by 6. This is a required answer. Now next example. In a meeting, 70% of her members favor and 30% opposed. A member is selected at a random at we take x is equal to 0 if he opposed, and x is equal to 1 if he is in favor. Find e of x and variance of x. I read again. In a meeting, 70% of the members favor and 30% oppose. A member is selected at a random at we take x is equal to 0 if he opposed, and x is equal to 1 if he is in favor. Then find expectation of x and variance of x. Solution. It is given that p of x is equal to 30%. 30% means 0.3 because total probability is 1. Now 30% of 1 is 0.3 and p of x is equal to 1. It says 70%. 70% members in favor. Therefore, probability 70% of 1 is 0.7. Therefore, the probability distribution is as follows. We know that the expectation of x is summation of xi into pi. Here where variance are 0 and 1. Probability of 0 is 0.3 and probability of 1 is 0.7. Now putting these values, 0 into 0.3 plus 1 into 0.7. 0 into 0.3 0 and 1 into 0.7, it is 0.7. Therefore, expectation of x is 0.7. Now find e of x square, means expectation of x square. Its formula is summation of xi square into pi. 0 square into corresponding probability is 0.3 plus x probability 1 square into its probability is corresponding probability is 0.7. Now 0 square 0, 0 into 0.3 0, 1 square 1 into 0.7 0.7. Therefore, expectation of x square is 0.7. Now, the formula of variance is variance of x is equal to e of x square minus e of x bracket square. Here e of x is 0.7 minus e of x square is 0.7. Putting this value, also e of x is also 0.7. Put here. Now, first term as it is 0.7, square is 0.49. Now taking this subtraction, then we get answer is 0.21. Therefore, required variance is 0.21 and expectation is 0.7. Thank you.